Welcome students to my Java classes. This is a continuation video under the topic flow of control. In this video we are going to see nested if-else, which we have already discussed in the previous video, but here few more skills are going to be discussed which you must acquire before going to the next topic. If you are starting with this video, then I would recommend you to definitely go and watch the previous video on the same topic, because if you watch that video, the proper and complete sequence of learning is going to happen and you will understand what we are going to discuss in our forthcoming videos. Now this video is to check whether the input here is leap year or not. So this is a very basic example which you will see every classical book takes up to make you clear about nested if-else, along with how to convert nested if-else based programs into a simple standard if-else block. Now this case we are going to actually conceptualize the logic in form of a nested if-else, and the same flowchart, same logic will be squeezed to a simple if-else based problem solution. So moving ahead, now the year is to be checked whether it is leap year or not. And what do we know about leap year? We know that leap year has 366 days and a non-leap year, which is ordinary year, has got just 365 days. So there is a difference of 1 day. Now the question is not to ask the user how many days are there and to check whether that 366 days then it is a leap year. That is not the question. The question is we are going to accept the year, like year 2019, and looking at 2019, how will we identify whether it is a leap year or not? Now the concept of leap year has come to adjust the calendar year with the actual time taken by our planet Earth to revolve around the sun. Now a calendar year is exactly 365 days in a normal way. In a standard calendar, 365 days are there for ordinary years. Now every revolution takes 365 days and some additional hours. In our elementary school, we are taught that it is 1/4 of a day. That additional time is 1/4 of a day, and so after every 4th year it accumulates to make another day, which is counted in the 4th year's calendar in the month of February, being 29th February. Now if it is 1/4 of a day, after accumulating 4 years it is getting additional day, then the calculation goes perfectly fine. But in reality, if you Google it, you will get to know exactly what is the time taken by Earth to revolve around the sun. It is not exactly 6 hours, it is 5 hours some minutes, which is very close to 6 hours. So what is done? It is not like every 4th year is a leap year, because if every 4 year is a leap year, then again the adjustment of calendar year and the time taken for the revolution will not match, and we are going to end up with a mismatch and an error in the time calculation for years. So what is done? There are two basic rules. Rule number 1 is made for year which are non-century years. So for a non-century year, after every 4th year it is a leap year, and next rule is for century years. So after every 4 centuries, a century year is a leap year. So now I'm going to take you to the logic of the program. Now here I've drawn a flow chart for you so that we can figure out how to find out whether it is a leap year or not. Now in rule 1 I've said for a non-century year, year should be divisible by 4, and for a century year should be divisible by 400. Because after every 4 centuries means what? It is divisible by 400. Now to figure this out, what we have done in the flow chart, let us see. We have accepted the value of year as y. Now if y is century, so what is going to be the programmatic way of checking whether the year is century year or not? We are going to check whether it is ending with 2 zeros or not. And to do so, we are going to use the very common operator, which is the modulus operator, which after dividing the first number by second number gives us the remainder. Now if y mod 100 is 0, that means if y after being divided by 100 gives me remainder 0, it is a century year. Now if it is a century year, what to do? We have to check whether it is divisible by 400 or not. If it is divisible by 400, it is a leap year. And if it is a century year but not divisible by 400, that means it is a non-leap year. Say for example, year 1600 or year 2000 is a leap year. Why? Because 2000 is divisible by 100, so coming towards yes, and 2000 is also divisible by 400, so it is leap year. But year 2100, is it a leap year? Because the next century year which we are going to approach is 2100. So 2100 is going to be divisible by 100, so it is a century year, but it is not divisible by 400. So the next century year which is we are approaching is going to be a non-leap year. So here if you see, we have covered if it is a century year, when it should be a leap year and when it should not be a leap year. And similarly, if it is not a century year, for ordinary years the calculation was to be checked for divisibility by 4. So if the year is divisible by 4, it is a leap year, otherwise no. So we have taken 2 blocks. This is one of the if-else block, this is another if-else block, and they are nested in both sides of this if. Like if it is yes, then also one if-else block, and if it is no, then also another if-else block. If you remember in the previous video, we have checked it for only 3 branches. 3 branches where first condition was giving us one direct result, and when the first condition was false, we were going and meeting another condition set which was giving us 2 results. So altogether we have seen in the previous video where 3 branches were coming out, but here we are finding ultimately 4 branches coming out at the same level. So be it any case, we now are going to check how to code the program for it. Now in order to show you the code, I have brought you to BlueJ IDE, where I have already written a little part of the program so that I can write the program faster. So what I have to do is I have to take the year. For that I have kept a variable y. Now what I'm going to do is I'll be taking the input. So I'll write system.out.print, enter the year. Now after putting this on the screen, what next is going to happen? I'll be writing y equals to sc dot next int. Now with this I'll be able to accept the value of y in my program. Now what to do? We need to implement the condition. Now in this condition, what we have checked? We have seen that one if block is there which has got another if block if it is true, and one more if block if it is false. So nesting needs to be done in a very typical manner. So I'll show you how the nesting has to be done. I'm taking you back to the editor. Here I'll write if y is divisible by 100 to check whether it is century year or not. Now, if it is yes, then in that case what to do? I will put it inside this block. I'm not writing it now. But if it is not, then in that case what should be done? I'll be writing it exactly inside here. So what shall I do? I will write if it is divisible by 100, that means if it is a century year, we need to check whether it is divisible by 400 or not. If it is divisible by 400, there we need to check I'm just writing leap year, or I can write y plus is a leap year, and if it is not, I can write, I'm copying it again, is not a leap year. So what should happen if it is divisible by 100? I should check whether it is divisible by 400 or not. If it is divisible by 400, it is a leap year. Otherwise, it is not a leap year. And in a similar fashion, I actually need to code for the next block also. So it's going to go like this. But here, I will not check whether it is divisible by 400 or not. It is to be checked whether it is divisible by 4 or not. With this, my coding is done. Now I will compile my program. Now let's see. Program has got compiled and there is no syntax error. So I will take you to the window where I will check whether the code is working or not. Now the output is being shown. I'll be checking whether year 2019, the current year, is leap year or not. So 2019 is not a leap year, it is saying. I will run it once more to confirm some other entries also. Now whether the year 2000 is a leap year or not. Yes, it is a leap year. Once more, let me check whether year 1700 was a leap year or not. No, it was not a leap year. So like whatever we have discussed and whatever we have written, the program is working on the same platform. Now something needs to be seen. If I consider this case, here you will notice that definitely there are 4 branches which are coming out, but basically there are 2 set of inputs. That is, in 2 cases it is leap year and in 2 cases it is a non-leap year. So if I can combine all the conditions together, then with a single conditional block I will be able to define this program. So our target is to understand how to code nested if else in such cases, plus to find out possibilities whether it can be squeezed or not. Now in order to squeeze it, what we can figure out is, in 2 cases the year is a leap year. The first case is what? Year should be a century year plus year should be divisible by 400. Now my friends, tell me, if something is divisible by 400, then definitely it is divisible by 100. So do we need to explicitly check that it is divisible by 100 also and it is divisible by 400 also? It sounds a little silly. So what should be done? We can simply check whether the year is divisible by 400 or not. And if it is divisible by 400, that itself means that it is a century year and it is the 4th century year. So it has to be a leap year. So I am covering that as a leap year. Now when in the other case it is going to be a leap year? If it is not a century year but divisible by 4. So we can come up with a conclusion that if y is divisible by 400 then it is a leap year, or y is not a century year but divisible by 4. So now how to write it in a programs context. So if we need to write it in the programs context, let me show you another flowchart which is very similar to it. Now here you can see the structure is simplified. It is not at all a nested if-else structure. It is in form of a big condition, which is not a single statement based condition, rather it is multiple conditions together. So we can figure out that this case also is checking whether the year is divisible by 400 or it is not a century year but divisible by 4. So if it is yes, then in a similar case it is going to be considered as leap year, and if it is not the case, then in all other cases it is going to be considered as a non-leap year. So there is a possibility of bringing those conditions together to define this compound condition. Now what is a compound condition? Compound condition are those where multiple conditional statements are joined together using logical operators. Now what are logical operators? These are the operators that tell us how multiple conditional statements are going to interwork. Interwork means work according to each other's state. Now in this case we are going to see that we have two conditional operators or logical operators. One is or and another is, I'll not say but it is basically the form of and. Now what is the work of and? The work of and is to check whether both the conditions are true or not. To understand it, I'm going to give you a very simple example. Say some guest comes to your home and you are alone at the home, and you are not basically very familiar to the stuffs which are there in the kitchen. Now you want to serve him a cup of coffee. Now for serving cup of coffee, what do you need? You need coffee to be present there, milk to be present there, isn't it? So let us just consider for now that the main ingredient of coffee is milk and coffee powder. Now you will be able to serve coffee only when you have coffee powder and milk. When both are available, then in that case only you will be able to serve the person with the coffee. Now and means this is going to join two conditions. Say if this is condition 1 and condition 2, if joined by and, then if both are true, then only the collective nature is going to be true. And in a contrast, what is the meaning of or? Say for example, if I tell you that I want to write a letter, and for writing a letter I need a pen or a pencil. Now when will I be able to write? If you provide me with a pen, if you don't have pencil, and if you don't have pen, then you will provide me pencil. And in only one circumstances I will not be able to write the letter, if you don't have a pen as well as you don't have the pencil. So in a very simple way, and says both should be true, then only the final thing will be true. and or says anyone if is true, then the final condition is going to be true. That means in this case what is going to happen? If this is true, then this needs not to be checked also. Straight away we can say that the wholesome condition is true. I'm taking an example. Say for example, if I consider year 2020. Now year 2020, if I go according to what I have drawn in the flow chart, is it a century year? No, it is not a century year. That means the first part of it is satisfying. And is it divisible by 4? Yes, that is also satisfying. So what we can understand here, if the first is satisfying and the second is satisfying, the whole thing which is there put inside the bracket satisfies. Now if this satisfies, do we need to confirm whether this is satisfying? No. Why? Because any of them if satisfies, we are going to go towards yes and we'll say it's a leap year. Now in a similar fashion, if I consider the year 2000, now what is going to happen in this case? Now in 2000, in the flow chart we will see, is it a non-century year? No. So if it is not a non-century year, even if it is divisible by 4, will this be true? No. Because and is used for joining these two conditions. Now in that case, both needs to be true. Now what will happen in the next case? If this is not true, that means the part which is within the bracket does not give us true, then in that case I should ensure that the other one is true or not. That means if it is said that I don't have a pen, I should check whether I have a pencil or not. Because if I have a pencil, that also has got a possibility of like satisfying me. Now year 2000 is divisible by 400. So what will happen? Any of these two here get satisfied. So I will say that it is a leap year. Now in the case if it is 2001, just consider that the year is 2001. In that case what will happen? Is it a non-century year? Yes. It is divisible by 4? No. So yes and no will ultimately result in no. Now that's not all, because here there is no, so we need to ensure that whether the next one is yes or no. So year 2001 is not divisible by 400 either. So what is happening? This is no, this is no. So in the case where both are no and we are using or, the whole thing is going to give us a no. So where will we go? We will go towards no and we will print a not leap year. Now in a similar fashion, if it is year 1700, now let's see what happens, because we are going to try the program using this concept only. Now if I put year 1700, is year not a century year? No, it is a century year. So if it is a century year, do we need to check this? No, because if this is no, no and anything will ultimately result in no only. So there is no point checking it also. So I will go and check whether this is possible or not. Is 1700 divisible by 400? No, it is not divisible. So in that case, this is also no, the next part is also no. So I will come up with a no as conclusion, and we will say that year 1700 is not a leap year. So in this case, we have seen how we have squeezed that whole big program where 4 branches were coming out, but 4 branches were actually resulting 2 possibilities, whether it is a leap year or not. So we could squeeze it to one simplified flowchart where only one condition is there, but a compound condition definitely. That is only capable of deciding whether the year is leap year or not in one single step. So now we are going to check how to write the code for it. So I'll take you to the BlueJ IDE. So this is the previous program. Now what I'll do is I'll make certain changes in it. I will write I'll not require this whole big block of code in my program. That much will be sufficient, but I will require to put in some more details into it. So what I'm doing is, I'm going to check. Now this is known as double pipe, and this double pipe symbolizes OR. So we have written y is divisible by 400, that means it is a century year as well as the 4th century year. So this only combines both the conditions, like y is divisible by 100 and y is divisible by 400. Now what we have to check, if y is not divisible by 100, so how to write not divisible? Exclamation mark and then equals to. So this is the relational operator to write it. Now we will write and. And is written like double ampersand symbol. So whenever you want to combine two conditions together and you want both to be true, to be concluded as true, then in that case it should be with and. Now y mod 4 equals to 0. Now that's it. One more thing I'll tell you. In the flow chart, if you remember, I have put it within a set of parentheses. But when initially I wrote it like this. Do I need parentheses? No. Why I don't need parentheses? Because if you see, there are two logical operators. One is OR, another is AND. So now, just the way in mathematics we follow the priority of operators called BODMAS. That means in an expression, if there are multiple operators, say for example multiplication as well as addition. Now which will take the priority? Which will happen first? Multiplication will happen first. That means multiplication operator has got higher priority than addition. So in this case, even if we don't put the parenthesis, AND has got higher priority than OR. So definitely this is going to be checked first and then it is going to come to check this. So this is my complete program. Let me try whether this runs or not. So it is showing no syntax error. So I'm going to check it. So for checking, I will go here. I will run it. So first I'm going to check it with year 2020. Now it is going to be a leap year. I'll once more check it with 2019. It is not a leap year. In a contrast, let me check a century year which is not a leap year. So century year, 1700 is a century year, but it is not a leap year. And let us see a century year which is a leap year. So year 2000 is a century year as well as divisible by 400, so it is a leap year. So this is how we are going to conclude this video. What we have learned in this video? We have learned how to make a nested if-else structure and how to implement that in a coding form, that is in Java. Plus, one more thing we have learned. We have learned to find out the possibility whether that nested if-else structure can be squeezed. That means individual conditional statements can be joined together to form a compound conditional statement. Like there are 3 conditional statements and are joined together to frame one compound condition. This is also we have seen, and whether this is possible to squeeze the program also or not. In that order, we have learnt about 2 more things. One is the role of OR and role of AND. So my students, I would like all of you to implement these things and then explore more such problem solving systems. Keep coding, and if you find any difficulty or you have any query, please put it in the comments below. I will definitely cover that in my upcoming videos. The next video is going to be on switch case nested switch case and conditional operators. Plus, I will be also taking a short discussion on nested if-else, where when the nesting or the ladder of if-else is made, there how we need to arrange the order of conditions. So we are going to do few more programs on nested if-else. But in this video, that's all. Keep coding and feel happy and enjoy coding to your enhancing your skills of programming. Thank you.